Assalamualaikum. Hi everyone. We are still in the topic of hypothesis testing, and in this session, I will focus more on hypothesis testing for two dependent sample. We have learned before two independent sample, but this time around is two dependent sample, or sometimes they call it paired sample. So I will divide my lecture into three parts. The first one is on the fundamental or the conceptual aspect of hypothesis testing, particularly for dependent sample. Second, as usual, I will show you the manual calculation step by step for the hypothesis testing until we reach the decision and make a conclusion. And the third part is I will show you the how to use Microsoft Excel to run hypothesis procedures. Okay, so let's go and see how we do it. We have learned the hypothesis testing for two independent samples in the last session. And this time around, I will explain the concept and procedure for hypothesis testing, but not for two independent sample. This time is for dependent sample, two dependent sample, or some we call it paired sample. So let's go how conceptually we should understand the testing and also the procedures. For this kind of testing, basically we will have two set of populations. Okay, we call it related population. Okay, or some we call it paired or mesh sample. The same thing, but different book will have different names. And basically, if for example there are some measures or observation or data that we take, okay, in term of the data taken, the nature is using the repeated measures, meaning that before and after, for example. Okay, so in order to know whether there are differences, the data that we take before and the data that we take after, so we have to find the differences. So this is the way, the formulas to find the differences. The d equal to the first observation minus the second observation. Okay, this is the basic formulas. And the assumption is that first we will assume that both populations are normally distributed. So that's the reason why we are going to use the t distribution. And if it's not normal, somehow we have to go for second option where we have to retake a sample, which the sample must be larger. Okay. So this is the conceptual understanding. For example, we have two sets. The first one is the score before training, and the second set is score after training. So that's why we call it two population. The first is before, the second is after. And then the data must come from same source. For example, the first set of data okay, is basically we take from Mike. The second also must come from Mike. The first data come from Alia, the second data also come from Alia. So that's why we call it repeated measures. Okay, data come from come from same person but at different time, which is before and after. Okay, so this is the example of two set of population. So we go to the next sample. So the next example. Let's say here we assume okay, you have sent your staff to a customer service training workshop, and we want to know whether the trainings produce a different result in terms of number of complaints. Suppose if the training is good, is really effective, the number of complaints should be reduced. So we want to see the effectiveness, for example. So we should compare the number of complaints before and the number of complaints after. So this is, for example, the stuff that we send to workshop, AJ, SZ, this is the name of the staff. And then we have two set of data. First one is the number of complaints before 62304, and also the second set is number of complaints after 4620 and 0. Next, manually we should calculate the differences. Okay, the data after minus the before 4 minus 6 negative 2. So this is how we get the differences. And then from here we got the average. Okay, the average of differences. This is the formula. We total up all the data and then divided by the number of data and then this is the formula for standard deviation. Very simple and very straightforward. Next, uh, we have to calculate later on we have to calculate the t statistic, but before that we have to know that t critical value. Okay, the t statistic, this is the formula, and then once we got that we have to see also the degree of freedom to get the t value. Okay, so let's go straight to the procedure. Okay, first we have to write the null hypothesis. SO is basically the null hypothesis. Mean differences is equal to 0. So meaning that we are assuming there is no difference in terms of number of complaints before they go for training and after they went for training. Okay, so 0 means here no differences before and after in terms of number of complaints. So we want to prove that this is the alternative hypothesis. We want to prove that there is a difference in terms of number of complaints before they went for training and after they went for training. Okay, so not equal to 0 meaning that there are differences. So the third is that we have to specify this is what we call significant level 0.01. This is the t statistic that the d average that we calculated before, and this is the t critical value. We got it from the table with alpha 0.01. When we look at the t table, so the t value is plus minus 4.604. Why plus minus? Because here, okay, the sign for alternative hypothesis not equal to, so that permit us to apply the two-tail test. That's why we have plus minus here. After we know the critical value for t, next is that we have to calculate the t statistic. So this is the formula. Okay, the t d average, the difference average, negative 4.2 minus the mean for differences 0. Okay, so divided by this is basically standard error. Okay, then based on this, the t statistic we get negative 1.66, and we compare based on this. We know that negative 1.66 basically fall within the acceptance region. Okay, within the acceptance region. So because of that, the decision is that we do not reject the null hypothesis. The conclusion is that there is not a significant change in the number of complaints, or we don't have sufficient evidence to reject the null hypothesis. Okay, so that is the basic calculation and the fundamental understanding for the dependency test sample. I will show you later on how to do the testing using the Excel. Okay, now let's see how we run the data analysis using Microsoft Excel. We will still use the same data set. Okay, the number of complaints before and after. First, we should key in the first group of data, which is before. Okay, first group of data before 6, 20, 3, 0, and 4. Next, second set of data we should key in after. Okay, so finish two procedures, two key in data. Okay, two set of data. Next, we should do the data. Go to the tab data, and then data analysis. We select t-test pad to sample for mean. Okay. First, we should put the first variable range here. Okay, here. So this is the range data that we should put. Second data, variable number 2 after. Click here and then this is the range of data. Okay. And then we should put here 0, hypothesis mean differences 0. Label no need because when we put the range, we don't include the before after, so leave like that. Alpha is basically 0.01, not 0.05, 0.01. Output range, this is basically where we want to see the result, the output. Okay, let's say here I will specify I want to see this here. Okay, the result should be here, they will put here, then just okay. Okay, so this is the result. Okay, so I can make it longer here. Okay, wider the column so that I can see the mean 6.6, observation of course 5 because we have 5 data, 1 2 3 4 5. Okay, 5 pet data. Since we have the hypothesis that we have is two-tail test, we should read this. Okay, we should read this two-tail. This is the p-value in order to make decision whether we want to accept the null hypothesis or to reject the null hypothesis. As we mentioned before, we should compare the p-value and the alpha level. Now the p-value is 0.17. The alpha, okay, the alpha value we know that is 0.01. So comparing these two, okay, this we know that the p-value 0.17 is larger than 0.01. It means that when the p-value larger than 0.01, we do not reject, okay, we do not reject the hypothesis, the null hypothesis. Okay, so that's the conclusion here. Okay, we do not reject the null hypothesis. Okay, this is the conclusions. Why? Because the p-value less than the the p-value is greater than the alpha value. That's it. Thank you.